Hello, welcome to NFI online video tutorials. In this video we are going to learn about Siemens PLC. The model we are using is S7200. So that's the PLC we are going to use in this series of videos for understanding the various programming functions of the Siemens PLC in ladder logic. So let's start with its wiring terminals. If you look at this PLC, in the top you can see Q0012 up to 7 and Q101. So these are the digital outputs of this PLC. We are using the model S7200 with CPU 224XP in which we have digital outputs. Alright, and the bottom you'll see I0, so I stands for input, Q here is the output. So from I0 to 0.7 these are the inputs, then another set of inputs up to 0.5. Right, so let's see that in how does this look in real PLC module. So I'll open the camera in which I have a PLC trainer, and here I will highlight you a few of the inputs and outputs of this PLC. Then later on we'll see its wiring diagram for clear description and wiring terminals. So that's the PLC we are using, and this is the programming cable. So let me take my camera to a little closer so that you can see what is happening here. So initially you can see three LEDs here. This states that SF diagnostic, one is run, another is stop. So right now PLC is at run mode. As you can see that this run LED is on. If PLC is at stop mode, this stop LED will be on, and if it is at diagnostic mode, then this LED will be on. Alright, now here you can see Q0 and this is Q1 and this is 0.0, 0.1, 0.2. These are the outputs of PLC, and these are the LED indications. So here we have to connect the output, and how to connect the output we'll see that in the wiring diagram. And over here if you see the top part of this part, this is the analog input and output of the PLC. You can see that it's a little dark here. This is A plus, these two are analog input, this is the common, and these two are the voltage input and current input of this PLC. So this is the analog input output part, we'll see that later on. And in the bottom if you see, here we have I0, and you will see, let me focus it. If you see this part, these are the inputs. This starts with I0, you have 0.0, 0.1, 0.2 up to 0.7. So these are the inputs. Then you have another set of inputs starting with I1, 0.0, 0.1, 0.3 up to 0.5. So this part of the PLC is the inputs, the upper part is the outputs. And here we have some more terminals, which we'll see what happens with these terminals in the wiring diagram. So this was a basic layout of how does a PLC looks like S7200. And in this trainer we have a power supply which works on 24 volts. These are some terminals of that. This is a main MCB which will turn it on and off, and this provides 24 volts to my PLC to power it up. In the bottom we have some relays which we are using to link our PLC with a DAC card. This is 4750 USB DAC card which we are using to control our software factory IO using this PLC. So this PLC is giving output to the relays, and relays are giving signal to this DAC card. That's how it's working. So let's see its wiring diagram to have clear understanding how it is happening. Alright, so that's the wiring diagram. So let's start with the digital inputs. How to wire the inputs. Now in the inputs you will see the first terminal is IM. Then you have 0.0, 0.1. If you see the PLC you will find these terminals. It goes up to 0.7. Then you have 2M, start with 1.0 and goes up to 1.5. Then you have M and L plus. So in the digital inputs you must be knowing about sink and source. So we have two types of wiring. One is sink wiring, another is source wiring. In sink wiring what happened, we have to connect 24 volts to the IM. Now IM is the digital common of the inputs. Input has a common. Okay, so we have to connect 24 volts to the common, and when you get 0 volt to the input terminals, this input will be active. Now let's take an example. We have connected an NO push button, and this is a toggle switch which is turned on. Now this is a 0 volt to connect it to one end of the buttons. Okay, so if this button is open, the 0 volt is not going to this terminal 0.0, so this will not be active. we have to maintain potential difference between the common and the input. So the common is already getting 24 volts. The moment input gets the 0 volt from the button, this will be on. If you see this case, the 0 volt is connected, so this button is closed. This is giving signal to this terminal. 0.1 is on, so this LED is on. This has been shown for this just demonstration. If 0 volt is going to the input and 24 is connected to the common, this input will be on. This is called sync wiring, right? The another wiring is source wiring. The only difference is here the common is connected to 0 volt. Okay, now 24 volt is being sourced from this input to the input of PLC. So this input is on, so this 3 is on. So this 1 is with respect to this one, second is to this one, 3 is to this one. So this input is on because 24 is given to the input and 0 is connected to the common. So this PLC has two common, one is 1M, another is 2M. So if you are using sync wiring for both the inputs, you have to connect 24 volt to here, alright, and 0 volt to here. This can also be done. It's not necessary to have sync and source wiring in the PLC. You can either have only sync, only source, or you can have sync source both. This generally required when you have different types of sensors. If you have PNP sensors, you need to use source wiring. If you have NPN sensor, you have to use sync wiring. That's where it is mandatory. Alright, so this 0.0 is the addressing of the input. We'll see the addressing part later in the slide. Now if you come here a little, you'll find two more terminals, M and L+. This is the auxiliary wiring terminal for sensor. Now this will give you 24 volts output. These are the output. You don't have to supply here power supply. No, you don't have to supply 24 and 0 here. It will give you the output. This you can also use instead of this 24 volt. If I don't want to use 24 volt from here, from external, I can connect that to here. This also makes sense. Okay, so this is 24 volt supply coming from the PLC. You can use for the sync source wiring. Similarly, in this M, I can directly short that with my M here because that's already giving me 0 volt. So this is 0 volt and that's 24 volts. So this two terminals can be used for wiring as well, but you can use 24 and 0 from external wiring or external power supply as well. Alright, so this was about the input part. If you see here, these are the ports for programming cable. If you see the camera again, these are my ports. That's my first port 0 and that's my port 1. This is used to link your PLC with your PC for programming. Alright, then if you come here, these are the three LEDs I have shown you. This is for diagnostic, this is for run, and that's for stop. Okay, and over here, this is the analog input output terminals. We'll have more understanding about these in analog tutorial. Alright, not in this one. Here we are going to understand only digital inputs and outputs. This is for analog, which will give you 0 to 10 volt, 4 to 20 milliamperes, or it can also take these signals to read it. Now digital outputs. Now if you see here, we have 1M, 1L+, 2M, 2L+, then M and L+, and we have couple of terminals 0.0 to 0.4, then 0.5 to 0.7, then 1.0 to 1.1. So let's start from here. These two terminals, L+ and M, is the power supply terminal of the PLC. Now our PLC needs a power. It needs the voltage to operate, to run the processor. So we need to supply 24 volts to L+ and 0 volt directly to M. This will turn on the PLC. It will power up the PLC. Right, this 16 number terminal, this is the earth. You can provide your earthing to this terminal. Then these terminals are the output terminals. Okay, so let's start from here. Now 1M, as we have connected 0 volt to this 2M, this is M here stands for low potential, L+ is high potential. So we have to connect 0 volt to M and 24 volts to L+. So what we have done here is we have short this M with this M, and then we have shorted that to our 0 volt of power supply. So 0 volt is going to this M, 2M and 1M, and 1L+ is shorted with 2L+, it's shorted with L+, and given 24 volts. That's the output wiring. Now this is a PNP type of wiring. This is the PNP type of PLC. This PLC will always give 24 volts if the output is on. So in this case, if the output is on from the program, okay, it's not that when the input is on, the output will be on. These will be linked by a PLC program. So in the program, if the output Q0.0 is on, this terminal will give you 24 volts as output. Okay, so if I connect 24 volt directly to an indicator and the another end is connected to 0 volt, this indicator will be on. Because potential difference is maintained between its two terminals. Here you are getting 24 volts, here you are getting 0 volts, so indicator is on. If output is not on in the program, this will not give you 24 volts. It will be an open circuit. So there is no potential difference of 24 volts, so indicator will not be on. In the case if we are using a DC indicator which runs on 24 volts. I hope this makes sense. So the output gives out only 24 volts when the output is on, because L plus is connected to 24 volts. In case if you connect L plus not to 24 volts but instead to maybe 10 volts here, then it will give you 10 volts output. That's how it works. So this was about S7200 wiring terminals. If you need this diagram, this is attached in the lecture in a PDF form. You can also download that and you can use for your reference. Okay, so let's proceed what we have in the presentation. Now the programming software. Now this PLC S7200 can be programmed with step 7 microwin. Now this software is you have to install the software in your computer, and this works best with Windows XP. But nowadays we also have some updates of Service Pack 9 by which you can use that on Windows 7 and Windows 8 as well. So more information you will find in the Siemens website. Now for programming we are using USB PPI cable. This is the cable we need to use to program our PLC from the PC. So this port over here goes to PLC, and this is a USB port which goes back to your CPU. Alright. Now input output addressings. As you might have seen on the PLC, it is written 0.0, 0.1. Let's see how this is linked to the addressing. Now in the input output addressing, the digital input addressing starts with I0.0 and goes up to 15.7. Okay, so the first input is I0.0 if you're going to take in the PLC. This will understand more in the programming lessons. The second input will be I0.1, the third will be I0.2, and so on. In the digital output addressing, it's more similar. The first one is Q0.0, the first output, second is 0.1, the second output, and so on. For the analog input addressing, now for the analog part which comes here, it has a different addressing. It starts with AIW0, analog input word 0, first input. Okay, it has W0. Second input is not W1 because W0 and W1 is reserved for analog inputs. So second input is AIW2, the second input. Alright, this is for input addressing. Now for the outputs we have AQW0, the first output. The second output is AQW2. Alright, and it goes up to 30. So you can connect multiple input and outputs in this analog as well. Now we have a bit memory. Bit memory is more like internal memory bits in a PLC. Just like we have in Allen Bradley as B3:0/0, in Delta as M0, in Siemens it's M0.0. One thing you must notice, if we are using 0.0, it means we are using bit addressing. Okay, here this is a bit addressing. This can only go on and off. This can only go on and off. Okay, so you have from 0.0 to 31.7 bit memories. Okay, now we have local memories. Local memories are used if you want to store some information. Information could be some counting the value of bottles or some objects, right? So this is LB0. This is byte addressing. LB0 to LB623. This is volatile. Volatile means its memory will wash away if the PLC is restarted. Then we have non-volatile that start with VB0 and goes up to VB2047. Now this volatile non-volatile memory will not be erased until you reset it by yourself, or the PLC, the battery is discharged, or you replace the battery. So this is B is for byte addressing. If your information is only up to 8-bit, use VB0. If your information is up to 16-bit, you can use VW0. If your information is 32-bit, you can use VD0. So it's VB, B for Bangalore, then you have VW, you can see that W here, then you have VD, D for Delhi. So you have VB0 to VB2047 non-volatile memory registers. Then you have special memory. Special memory are used in case you have some special function which you don't want to design, but you can use like of the PLC function itself, which you cannot create by yourself, but you want to use it in your logic. Let's see what are the different special memory functions we have. later in the slides we have a slide for that here. So let's see that here first. The SM0.0, this is always on. So if you need a bit which is always on without any external force, you can use SM0.0. Then later you can see in this chart we have so many couple of bits like SM0.4. It says 60-second clock pulse, on for 30 seconds and off for 30 seconds. It's automatically on for 30 seconds then off for 30 seconds. This is 60-second clock pulse. SM0.4 can be useful somewhere. SM0.5, 1 second clock pulse, on for 0.5 second, off for 0.5 second. This can be used for blinking operation. So you don't have to design a timer for that. You can use directly this pulse. Then let's say SMW24. It says word provide minimum scan time recorded during entire run mode. So now PLC is running in run mode. If PLC is in run mode, we know that there's a scan time which is the time taken by PLC to read the input, solve the logic and give the outputs. So it records the minimum scan time recorded, right? So these are some special memory bits. Now we have timer, counters and other addressing. In timers we have T32, T97 as an on-off timer with time base of 1 millisecond. We have 3 time base, 1 millisecond, 10 millisecond, 100 milliseconds. So on-off type of timers are 32 and 97, just 2 timers with 1 millisecond. We have retentive timers which retain the time. We have 2 retentive timers in this time base. So on we have for 10 milliseconds and 100 milliseconds, right? Counter addressing is C0 to C255. High-speed counter HC0 to H235. So these are the couple of registers and their addresses which you can link, which you can see from this chart, and you can save that just in case if you forgot the addressings. Alright, so this was a basic overview about the Siemens PLC and how to wire this PLC and how to use its addresses. In the next video we'll see how to download and upload the program in the PLC, how to detect the PLC with your software. So let's see that in the next video. Thank you so much.